You can hear me well? Yes. Thank you. I have to admit I'm rather nervous, so bear with me. So today I'm going to lie to you. Yes. Actually, I was not able to visualize networks. I failed miserably. So I had to find alternative solutions, and in the end, you'll see that some of these alternative solutions can translate into potentially promising avenues to deal with large, very high number of nodes and edges. So quickly, we're going to look at the fact that a lot of useful networks are often very large, and which makes them very difficult to browse. What I mean by browsing is real people, you and I, on a daily basis, just trying to figure something out to explore these networks. And I'll get into the specifics of semantic networks. Some people might call them ontologies, and the fact that these are often mostly empty, or the idea of sparseness. They are, in fact, a lot of them contain very few information items. And once we know this, we ask ourselves, well, if they're mostly empty, could we actually simplify, prune, or filter them, whatever you want to call it, to reveal the location of most information? Now look at the choice of word I've taken here, location, as in it's a place. Sure, assume it's a place within a network, even if that place does not map into a geographical location. It's something we can explore visually. Now, obviously, I'll go through this quickly. What's a network? We're talking about nodes and edges, so the lines between the nodes. This is probably the simplest network you'll ever see in your life, although I could have just a two-node network, so this is complicated. And then I could have a directed network. Ooh, the arrows. So that's the next step, where we can actually see a direction between for the relation. And then finally, we refer to instances, and this is what I find useful, well, this is what I find interesting, is the fact that these nodes, these circles, are actually containers for something. So they're actually providing access to something. And so how can we go about visualizing something that's like this, but times a million? And how can we make that useful? Now, I looked into the specific case of semantic networks, so some people will call them ontologies, and because they might offer the promise of a kind of information discovery or retrieval, maybe just an integrated alternative to just type in your keywords here and press search, because some of us, maybe none of you, but sometimes we just don't know the words. I'm sure all of you already know all the words, but I don't. So sometimes I look for words. So what are we talking about? We talk about semantic networks, talking nodes, in this case, topics. That's textual labels, easy enough. Edges, the relations between these topics. So a classical one we recognize is the broader to narrow topic, so it's a directed one from broad to narrow. This, what's within biology, could be microbiology, and so forth. This gives you a kind of hierarchical structure within that semantic network, and I say at least, because there would be other types of relations, of course, but at least you have this. I don't know if anyone could contradict me on this. I'm under the impression that all semantic networks would have a partly hierarchical structure to them. Has anybody ever seen a non-hierarchical part to a semantic network? Let me know. And then finally, the instances would be information items that you would access via the topic. So this is where it becomes interesting, and then I don't get up very many times in the morning and say, today I'm looking for new topics. And maybe some of you do. Most days I get up and I'm looking for particular information on X, Y, Z. I want a journal article. I want a website. It's the instances that are interest to me as my stated purpose. I may learn new things along the way that I didn't think so, but what I set out to do is look for the instances, generally speaking, as far as I'm concerned. Now, what are the promises that these things offer us? Why should I bother looking into this? Well, first of all, they describe a domain of knowledge. So again, if I don't know much, and I admit it, I don't know much. I know a little bit about a few little domains, but most of the times I know very little. And so they describe the terms, how we speak about a domain, the relations between the terms. So the promise is I'm lazy, and I don't want to have to read the documents. So I could learn a vocabulary without having to read the documents. Now, this should allow computers to make inferences too. There's no reason why not, and this is part of the promise of the semantic web. Actually figure out what people mean when they type in naive, broad keywords, or the opposite, they type in specific keywords, but the context can be diffused. Disambiguate messy natural language is an example I always like to use. If you type in depression in Google, Google will assume that you are clinically depressed. That is the sad fact, that most people, when they type in depression, they are clinically depressed. But there are different contexts, so instead of putting the onus on the user, when the user realizes, oh, well, but I'm not clinically depressed, so I have to tell Google I'm not clinically depressed, instead of putting the onus on the user to possibly provide some kind of guidance to the user that perhaps you want to disambiguate your search term. Did you mean in terms of geology, history, and economics, and so forth? And I believe English is one of the messiest natural languages because it grows organically through the colonies. And what was the, when I tell my students this sometimes, what is the criteria for a new word to appear in their English language? Anybody know this? The Oxford Dictionary will accept a new word as long as it's got, I think it's 11 public citations. So if anybody writes 11 times the same word, boom, it's in.
11 tweets?
That's a good question. 11 tweets, I don't know. So anything goes, essentially, in the English language. So the line between a billabong, a small pond, and a lake, I don't know. Okay, now, how can we allow searchers, therefore, to recognize instead of purely recalling? When I did my defense a few years ago, one of the examiners said, well, yes, but I can always type in new keywords to tell Google what I'm looking for. I just type in new keywords. And I was taken aback, and I thought, how can I answer that? I don't know the keywords type sometimes, I admit it. So if you're like me, this is a promise. Possibly evaluate groups of documents instead of one at a time. This is basically what we're doing now, right? We inspect snippets, and then we looked at the documents one at a time. We try to get an idea of broadly what's in this. Is it what I was looking for? So a group at a time, relevance evaluation, as opposed to one at a time. And this is a question I'm just throwing out there to just trigger some thought, is we're actually wondering now, is a folder tree, how many of you do not use a folder tree, to organize your files? So I've got one rebel. How do you organize your files? So you don't, is what you're saying. So you don't organize.
So you said folder.
How do you organize your file? Do you organize your files?
Like I put them into one folder. And then I search them. Full text.
Okay. So the assumption is you will always know a word that was in one of those files in order to retrieve it. And you're assuming that you will always remember all the words you've used in the past. All the words, at least some of them. So implicitly what you're saying is you're accepting that there are some things you may never find again. And that's fine to you.
Well, that's the case with folder organization.
Possibly. Okay. I guess what we're seeing now, there's a clear pattern that people seem to still find it useful to organize their files in their folder tree. And maybe you're the first of a new trend, possibly. But it seems to still be useful. So one of the things we're wondering is a folder tree a kind of semantic network? Obviously, the network is very simplified. There's only one kind of relation, broader to narrower. But you could say it's a light ontology, for example. So we have all these promises, and the problem we have is real-world semantic networks are often large and complex. The bigger the domain and so forth, history grows, and that becomes difficult to browse. So I looked into the case of LCSH, Library of Congress subject headings. It's all over the world in most of the world's academic libraries. And it's a very good example of we're trying to describe the world's knowledge over the past 120 years. So we've got an actual real-world example of trying to make this work. And so we're talking over 200,000 subjects, or nodes, for example. I'm not even going to tell you how many relations there are between. I mean, already we're in the huge numbers. If we look at a smaller domain, much more specialized, of MESH, medical subject headings, again, trying to make this work. This one's much more controlled because these are medical professionals in much more recent history. We're talking about 26,000 subjects. And the difference, obviously, here is that here it's aimed for the lay people, someone off the street coming into the library. Here it's aimed for medical professionals. Different types of objectives, but we clearly see a size issue, and we have all sorts of these types of semantic networks, ACM, CSS, the Amazon categories. They're all over the place. So this is an idea to just give you a broad idea of quickly how complicated, and Jean-Daniel gave us a good idea of these things can get difficult to consult. A few hundred nodes on the right, and we see what he called it the hairball effect. which is very good. We've heard it called the spaghetti effect as well, where one noodle is impossible to follow at some point. On the left here, we see some beautiful clusters, but in the end, maybe a few thousand nodes here, and the individual nodes cannot be discerned by themselves. So I get broad overview, but the details are occluded. So it quickly becomes a problem. And what do I mean by large? Because that's always a question people, how big does big have to be be considered large? It's a relative word. So we're saying that 100, 100 to 1,000, 1,000 to 10,000, 10,000 to 100. These are broad categories from this source. So really the biggest category was 100,000. Now, my reaction when I saw that, well, that's still pretty small. Like, I'm dealing with things that, I've got minimum of 200,000 nodes, subjects into a Library of Congress subject headings, and I'm not even counting the instances. The actual documents, there are millions of them in there. So large is very large, and you could argue a lot of semantic networks will be in the biggest category very quickly. So what is the problem with large? Well, you can have two sides to it. Either it's too big for the hardware, as in no matter how big your screen, you can have wall-sized display. Eventually, it'll still be too small. Generally speaking, for those who actually try to make systems, there's an arbitrary limit. We kind of have what they call a budget, right? You say, I got a visual item budget. I'm going to stop at 10,000. And then once you get beyond that, we just stop, because you get a practical limitation there. But the flip side of that is that eventually it's also too big for the brain. Obviously, you cannot take 10 million items at one time, so you got to deal with it. So one way or the other, you run into this large problem. So what are solutions? You can on one side manipulate the visual representation. We get some classic visual techniques here: magic lens, focus context, distortion. We'll look at these in a few minutes. On the other side is to manipulate the data. Before I try to visualize it, can I reduce the clutter? That's a broad domain of research where we're trying to simplify, filter, do some sampling, all sorts of techniques to make it smaller, to make it easier to consume. So if we look at the first side of it, and this is how I got into this. I had this huge network. I wanted to provide access to it because I thought it was cool and potentially useful. And I thought maybe it's just an interface design problem. So then I got to, obviously, information visualization. I got into reading a lot on it. And I was trying to fit a huge structure onto a small screen. Now, we got, obviously, some techniques that are known, 3D, which the promise here would be to offer an additional dimension. But as Ananya mentioned, there's often visual occlusion beyond 1,000 nodes. But it depends on how you place them. So even 12 nodes can become visually occluded, so difficult. Here, a more classical 2D node link, obviously. It's a hairball effect, also the spaghetti effect. So maybe I might have 300 nodes here, maximum. And the whole time I'm thinking, yeah, but I've got 200,000. What am I going to do? And then we go into classical focus context. There are some much more recent ones, but there's a whole slew of these things. It was essentially, I'll give you a lens, and you can blow up that part of the network, and we'll look at that. We've got distortion, obviously, where a region of interest is shown clearly and is surrounded or distorted so we can fit more into on screen. You got a whole series. Fisheye would be another example. Again, I'm using some of the older examples because they started a category, and there's plenty more in those categories. And then for about a 3-year period, I said, well, I'm going to collect a bunch, and I'm going to see a pattern. I'm going to organize them, and I started collecting, and I collected, and I collected. And I collected, and obviously every year, so this is about only 3 years worth. And obviously they're for different applications, different data, but I was left at some point with, okay, so none of them actually gave me a good solution to hundreds and thousands of nodes and the relations between them. So how do I go about this? So I took a step back and said, maybe it's not important to show the whole thing. Maybe that's my issue, is I'm trying to be too comprehensive. Maybe I have to look at what's important to show and reveal to the user. Let the user choose to reveal, to simplify or complexify the network. So maybe there's another way. Instead of trying to fit a large network into a small stream, why not reduce the size of the network? So I went about it and said, well, what do people do with these things? And I keep thinking of the example, does anybody know how the hologram was developed for credit cards? Physicists, optics specialists were spending years trying to develop little holograms. And it was an intractable problem because you had to take images of every angle, superimpose them, and it was intractable. And then at some point they looked at people looking at holograms, and they realized all they needed was 15 degrees this way and 2 degrees this way. The rest was useless because nobody ever looks like this. So then I started thinking, all right, so perhaps it's not so intractable if we look at what people do with this. Now, on one side, you could argue there's a human or automatic indexer that's trying to assign topics to instances. So what are these things about? So that's one task, which is going one way. I'm trying to categorize stuff. In my case, I was more interested on the other way. I'm browsing to find instances. So are these two things the same? I don't think so. The goal is different. So you could argue, should they use the same semantic network? I'm not sure. I think at the core, initially, in the case of human indexer, the semantic network, the ontology, was developed in part by them, for them, to allow them to categorize. And if you look at automatic indexers, we make decision trees, neural networks, to put things in categories. We don't make them to have people browse them. Now, I'm not saying these two don't overlap. I'm just saying, could we look at it that way? Could we modify it for the task at hand? This is where I got into this whole clutter reduction and how do people do this. This is a lot of examples of different approaches. But one of the two that I want to point out is filtering and clustering, which is another word for aggregation. You can have sampling. So some of the more popular approaches. So what I've gone and done is, well, if most of my semantic network is actually sparse or empty or quasi-empty, can I filter it out? Can I filter it out just to show where the documents are, as opposed to showing all the topics or the nodes that have very few things? So how do I go about do that? I started with the idea of a hierarchy, because most semantic networks have a hierarchical component. I thought, let's start with that, and then we'll scale up to other relations later. But the idea is that we all understand trees, we all understand hierarchies. All of us are used to interacting with them, except you, in their folder tree. And so can we start that as an interaction metaphor? And then later on add other relations, but at least it will be a recognized interaction metaphor. And I would argue this is how you get people to take up a new tool without forcing them to learn, is that you give them something they know and you tack on things they don't know onto that over time. Now, if a hierarchy is a tree, generally, if all nodes have only one parent, except the root node, and then there are no cycles. Now, this third one is interesting because I have found a lot of cycles in semantic networks, meaning one subject is actually a parent of itself. All strange things can happen in the real world, and that's very interesting. So one of the assumptions I'm taking to begin with is that, and I'm saying this because I've gotten a challenge on this in the past, is that users browsing a semantic network, people looking for topics, are actually looking for documents. Most users, most of the times. Now, they may learn something along the way through the node labels, but this is not their primary stated goal. And some people don't agree, but if you don't, let me know. We can talk about that. Now, given that semantic networks are actually sparsely populated by the information, as I've said, few topics are assigned to many documents. A small group. This has been verified in a lot of different collections and a lot of different organization schemes. But most topics are assigned to few or no documents. There was an information organization theorist that told me, yes, but that's because indexers devolve and they keep assigning the same one. And of course, my question is, what does devolve mean? It means they don't improve somehow. So yeah, they just keep assigning the same one over and over again. That seems to be what this person was saying, but my answer is, I don't know. This is how it is. Right now in the data, when you look at it, a few are assigned many times, most are assigned few times. So if you map this out, on the horizontal axis, I've got the 200,000 subjects of Library of Congress subject headings, and they go on until, what is that, south? No, that's, so that's about till Saskatchewan about. And on the vertical axis, I've got the number of assignments for each of these. And obviously, you've noticed I've sorted them by number of assignments. So we clearly see a presence of a power law. So a very small group of subjects are assigned to a lot of documents. The vast majority of subjects are assigned to 1, 2. Now, obviously, I was very surprised by that because I thought the whole point was to group things together. And so groups of 1 or 2, I don't know what that is. That's a group. Okay, so I thought maybe why don't we filter down the network to the few topics that contain most of the documents. Maybe it's not complicated. Maybe it's not hundred thousands of nodes. Maybe it's just a few hundred actually. Let's see. So here's an example. I've got the implementation of the algorithm and the prototype. This will be for questions or another day or read the publications. But here's another example from medical subject headings. So we've got here a long string of 11 terms from organisms, which have a lot of different types of organisms, but then you have animals, and under animals at some point you have mammals, and eventually 11 levels down we get humans. Wow, okay. Now, when you actually look at where the mesh collection is situated, and I've gotten, my God, how many of them did I get? I got 230,000. Now, this is a sample, but this is about 20% of the whole National Library of Medicine collection, I believe, roughly. So I thought it was a pretty good sample. And what you see is actually, no, it's not like that at all. Really, there are different kinds of organisms, but the vast majority of the literature talks about animals. Not surprising. There are different kinds of animals, but the vast majority talk about mammals, the different kinds of mammals, the vast majority talks about humans. So we've gone from 11 levels of abstraction that most of them are empty, very few documents assigned to them, down to 3, where we still have, and I stress this at the top, 100% access to the collection. We have not lost any access to the instances. We have lost some of the descriptive power of the hierarchy. I don't deny that. That's fine. I'll get into a few minutes where we'll let the users choose. I don't pretend to know what they should have. We'll let them choose. Here's an example from Library of Congress Subject Heading. I find this thing fascinating because this is the real messy, dynamic world. Someone from biology or life sciences may have to explain to me at some point how the growth of plants is actually eventually a descendant of the morphology of animals. Now, I'm not an expert in this subject, but I think this is a great example of how these things, over 120 years, I mean, LCSH has a long history, and actually when you look into it, you realize, yeah, but if I look at each individual broader relation, they all make sense. As in, plants growing media is indeed a narrow term to growth of plants, and if I just look at the growth of plants, it is indeed a logical narrow term to growth. Okay, now stop there. Don't go any further. Just look at growth. It's itself a good narrow term for the morphology of animals. What's happened in LCSH is that very few attempts have been made to inspect chains of narrow terms. Each individual relation was assigned, but the chain was rarely inspected. So I find this wonderfully interesting because it shows the real messy world out there. So when you look at where the collection is actually distributed, we see a much shallower tree. In this case, obviously there are different kinds of life sciences. Biology is by far the most populated, where most of the instances are. And then within that, we have a few levels to get to the growth. Now, this is an interesting one because LCSH, in this case, I've taken out that weird set of relations because the growth of plants has been knocked out. There's very few items assigned to it. So in the example on the right, this seems less ambiguous, less complicated, because growth, yeah, makes sense, and then underneath soils, maybe. But we're seeing where we have here a much shallower and narrower topic hierarchy. Another example from LCSH, did you know that engineering is actually eventually a descendant of medicine? Well, now you know. Well, look at the chain. In a way, the chain eventually tells you how this may have happened. It's not, and you could argue that the biomedical engineering crosses the lines. So you've got a long chain through physical therapy, and then handicraft, industrial arts, and under industrial arts engineering. Obviously, you can guess what happens here. Engineering is probably huge. Everything gets collapsed, and right under medicine, we get engineering. So again, we get the result that we have a much shallower tree where still the vast majority of the collection, most instances close to 100% of the collection is still accessible, but a much smaller tree, much easier to browse. So how do we know that the filtered network is actually easier to browse beyond the idea that simpler is better? It's often a strong argument, but so we wonder how could we quantify the difficulty of browsing. So we went about it doing a very impressive scientific formula with a combination of means and standard deviations. And so we broadly have the mean number of children per node, standard deviation of children per node, times the number of leaves to root. So in other words, how many narrow terms are you offered on average at each parent term? Hundreds? Dozens? So how many do I have to choose? And how predictable is it? Do I wildly fluctuate from 2 to 100? Or can I pretty much guess that at any point I'll get between 5 and 7? And then we multiply that by the number of these decisions that you'll have to make before you reach the boundaries of the tree. Okay? Now, I'm not saying this is the one-all end-all. It's just we try to keep it simple for initial attempt and see if this could describe the difficulty. So really what we're saying is we're trying to quantify and compare the effort required to browse a particular subject structure. And a lower BC score, browsing complexity, would tend to produce shallower and more balanced trees. What I mean by balanced trees is that if we reduce the standard deviation, we'll get less branches that are hundreds of nodes wide, versus 2 nodes wide. We'll balance that out a bit more. So this is the objective with this particular quantification. So this is a prototype we've done to explore this. What we've got on the left here is the original structure. This is, in this case, the mesh structure. And on the right here, we called it the reduced structure. We tried to make this simple and so the user would have to kind of understand actually what works. The slider here is strictly a modification of the sensitivity. What am I willing, how significant does a topic need to be for me to see it? So in this case, halfway down, we see that the same area of the tree is much smaller. In this case at the left, I have to scroll to see it. On the right here, by choosing to see fewer subjects, I reveal the whole section without having to scroll. So you let the user decide when it is pertinent to see only the areas of the network, of the tree in this case, that contain the vast majority of the collection. And the idea is to integrate this within a full browsing searching system where you would figure that, okay, people want to search, and that's fine. So how would that interact with a semantic network, in this case, semantic tree? And the idea of being able to reduce the tree down to only the nodes that contain most of the information. This is where I've been privileged to be given a grant to do this, to explore the boundary between browsing and searching and how these things should work between structured and unstructured information and how do we combine these things. Because right now we see a lot of either traditional information retrieval stuff in unstructured information. We search for words and we do ranking. And on this side, we see a lot of browsing stuff, purely browsing. How do we integrate those two? And how should they live together? Now, how would we situate this? Obviously, this is a sparse graph type of setting where we have a small world as well. So the network there's only a few areas that contain a lot of stuff. And the small world is that there's a few nodes that talk to each other a lot, but most nodes aren't connected very much. And we're trying to do clutter reduction, and generally what that means in terms of filtering is that people select interested values or of non-interest, and then you make those disappear or appear depending on how you've set up your interface. In this case, what we're trying to do is filter based on the document accessibility provided by each node. Now that's different than than the number of assigned documents, right? The number of assigned documents is how many documents have been assigned specifically to me, and accessibility is from me, how many documents can you reach? So what am I a gateway to? So that's accessibility. So which is a kind of filtering based on a calculated node property, where the user can figure, show me a few nodes that contain most of the instances. All right, I like this area. Show me a few more nodes. Show me a few more nodes. So you could say this is kind of like a dynamic or user interaction controlled multi-scale or multi-resolution of, in this case, a topic hierarchy. So this is situated in types of other prototypes you might see out there. Now, how do we see this generalizing? We don't see why this shouldn't apply to any organized collection using any type of topic hierarchy. So right now we're looking at libraries, scientific collections, museums, and I have a student looking in folder trees. Could this apply to folder trees? Whether it be on a shared server, whether it be on a personal computer. And but we're wondering if it could actually apply to any network that contains instances. We need the instances to know where is the information situated, but that remains to be seen. So to recap, at this point, if you have anything to remember from this, is ultimately they're often large, difficult to browse, but they're often empty, these semantic networks, in a lot of places. So can we simplify and improve semantic networks to reveal where the most of the information is located? And that's kind of what we've tried to do. And let the user decide when it is useful to him or her. So thank you if you have questions, but I'd like to preempt your questions with those that I'm no longer interested in. So some of them I've received often would be something like, everybody know what facets are nowadays? And obviously some people tell me, well, don't facets make subject structures useless? And obviously my answer to that is no, because ultimately facet browsing ignores the structure, it flattens it out, it becomes a one long, so there are no relations between subjects. So I would argue if the user could actually easily access the structure, maybe we might give the structure a chance to be useful. So that's my answer to the facet thing. Is the logic of the structure respected? That word, I don't exactly always know what it means, but what I can tell you is yes. Broader subjects stay broader. What's eliminated is quasi-empty levels, meaning they don't switch around. So if there was broader, it stays broader. So in those terms, the logic is respected. Then I get I/O theorists saying LCSH, mesh, semantic networks generally are not hierarchies. That's not a question. They make a statement usually. And to that I can only answer, you can always, and we've shown it with LCSH, I love LCSH because everybody was telling me don't go there. It's barely controlled chaos, you'll never make heads or tails about it. And that's usually a great hint to, well, that means I'll pretty much be the only one there. And so we've shown that you could extract the hierarchical component of a network and use that and rebuild it and to use it as the interaction metaphor. Of course, the question of loss of collection. Is this a lossy algorithm? Do we lose access to the documents? No. Okay, what we can do easily enough is simply move the documents assigned to prune subjects to their nearest retained parent. So we still provide access to the document. We do lose a portion of the specificity of the subject indexing. So, but there's no collection access loss. So, but I would argue this is very good for the grouping function. We no longer get some of these groups that have one document in them. We get groups that have a sizable number of documents. How do you know this is any use for users? Good question. We don't. Now, obviously, usability tests would need to be done. I've done some usability tests with IV interfaces, and I get shut down systematically because I have to ask people to do something with it. And as soon as I ask people to do something with it, someone shoots me down as well. If you would ask them to do something else, you would get different results. And they're right. So I've taken a step back from that because the whole task testing and which tasks, I just don't know what to do. I just don't. So that's where we came up with this BC scores. Can we have a quantifiable way to say how difficult it is to browse? And of course, what's next? We're still working on this. I had a viewer call the browsing complexity measure, what he said, pseudo-scientific attempt to complexify the simple. And so I figured maybe I'll throw in a log at some point that always impresses people. Or all I'm saying is there's probably things to be done with it. And obviously, right now we're testing across collections and different types of subject structures to see what it does. Okay, now, if you have any other questions, I'm more than welcome to. Thank you.